All right, class. Shh. Okay, class. So let's play this one more time. So we have a cell, and we know that inside of at rest we have more negative charge inside and we have positive charge outside the cell, right? Now, if the cell becomes permeable to sodium, let's say the cell becomes permeable to sodium. So where do we have more sodium? Outside the cell. We have less sodium inside the cell. So in that case, sodium will come inside, right? We will have influx of sodium from the extracellular environment. And can you tell me, when we have more sodium coming inside, what type of charge is entering the cell? You are right, we have more positive charge coming in. If we have more positive charge coming in, what will happen to the membrane potential? Well, the membrane potential will become less negative, more positive. So when sodium or positive charge comes in, the membrane potential becomes more positive, less negative. Okay? Okay, now can you tell me what will happen if the membrane becomes very permeable to chloride? So let me draw some chloride channels, and let's say it becomes permeable to chloride. Now chloride is more outside. We have a lot of chloride outside and we have little chloride inside, right? So chloride, as it comes in, what type of charge will enter the cell? Well, negative charge will come in. So the membrane potential will become even more negative, and it will move further away from resting membrane potential, right? So for example, if we think the resting membrane potential is negative 70, the inside is now even more negative due to incoming chloride ions, and it can go to minus 85, minus 90. Does it make sense? Okay. Now, listen carefully, when positive charge enters the cell, the inside becomes less negative, more positive. That state is called depolarization. So as sodium entered the cell, we had depolarization. Depolarization. Good. What happened as we had chloride entering the cells? The inside became even more negative and things moved further away from resting membrane potential, and a condition called hyperpolarization. Hyperpolarization. Okay. All right. Now, we see that as sodium enters, the cell gets depolarized. Now, what can the cell do in order to repolarize? What is repolarization? Let's talk about that. Repolarization. Repolarization is nothing but coming back to resting membrane potential. Membrane potential, or restoring the resting membrane potential. Clear? You might have few questions based on this concept. I can ask you, okay, the cell becomes more permeable to calcium. Is the cell being depolarized, hyperpolarized, or repolarized? Which way will calcium move? Which way will sodium move? Which way will potassium move? What is happening to the cell? Depolarization, hyperpolarization, or repolarization? You might expect some questions which you have to actually think about. So it's really important that you understand the concept. So let's review one more time real quick before we move forward. So at rest, we have more negative charge inside as compared to outside the cell. And this difference in charge is called resting membrane potential. Okay, if we have positive charge entering the cell, then the inside of the cell will become less negative, more positive, a state called depolarization. If we have more chloride ions entering the cell, the inside becomes even more negative and it moves further away from resting membrane potential, a state called hyperpolarization. And when the cell comes back to its resting membrane potential, the process is called repolarization. Now let's do it by a number line. Let's say we have this number line. We have 0 here. We have negative 70 here. We have positive 30 here, right? And then we have negative 55 here. Okay. Now, negative 70, let's say negative 70 is resting membrane potential. Negative 55 is threshold. And we will talk about threshold a little later. But right now, know that negative 70 resting membrane potential and negative 55 represents threshold. Okay. Now let's say the cell, we have a cell, right? And let's say the cell becomes very, very permeable to sodium. Which way will it move? Will it move closer to 0 or further away from 0? Remember, we are having positive charge coming in. So obviously, it'll move closer to threshold or closer to 0. So it'll move this way. This is depolarization. And based on the chart, we have entry of sodium, entry of calcium, and entry of potassium, which all are positively charged, will help in depolarization of the cell. Now, another thing, will depolarization move to 0 and then stop? No, it can move further. It can move all the way to positive 30 in this example. Okay, so it can depolarize and depolarize and depolarize to positive values. Good? All right, class. Hopefully, you know the concept. You understood the concept. It's so hard doing it via video, but I'm trying my best. All right. Okay. Now, let's say the cell becomes very, very permeable to chloride. So what charge is coming in? Negative charge, right? So will it move closer to threshold or closer to 0 or further away from resting membrane potential? Well, more negative. So it'll move further away from resting membrane potential. And this is hyperpolarization. Good. Okay. Now, if a cell is depolarized, so let me erase this. So let's say a cell is depolarized. Can it come back to resting membrane potential? Yes, it can come back to resting membrane potential by again movement of ions across the membrane, and this process is called repolarization. That's repolarization, coming back to resting membrane potential. Now let's say a cell is hyperpolarized. So let's say a cell is hyperpolarized. Can it come back to resting membrane potential? Yes, it can come back to resting membrane potential, and that is also repolarization. So from depolarized state, coming back to resting membrane potential is repolarization. From hyperpolarized state, coming back to resting membrane potential is also repolarization. Hope this is clear. Okay, now students often ask me, Rupa, why are the inside of the cell so negative? What makes it negative? Well, the reasons are multifactorial, meaning it has several reasons. But for this class, I want you to focus on three main reasons that makes the inside of the cell more negative. They are listed as A, B, C here, but they are not in order of importance. Okay, so let's draw a cell. We have negative charges inside and positive charges outside. Good. Now, why is the cell so negative? First, due to the pH of the extracellular fluid, we have some proteins inside the cell, right? The cell makes a lot of proteins. So these proteins, let's draw some proteins. Now these proteins are highly negatively charged. So the negative charged proteins that are built inside the cell, they are responsible, or they contribute to the negativity inside the cell. Secondly, we have our favorite sodium potassium pumps, right? We have sodium potassium pumps on the membrane, and these pumps actually help to push 3 sodium out and how many potassium in? If you remember, 2 potassium in, right? So what's happening here? Well, we are losing 3 sodium and we are gaining 2 potassium. Is that equal exchange, class? No. We are losing 3 positive charge and gaining 2 positive charges in return. So we are losing 1 positive charge overall, right? So that contributes to the negativity inside the cell because we are losing positive charge. And when we lose positivity, what do we become? We are negative. Same holds true for life. If we lose our positivity, we become negative, right? I am a positive thinking person for most part, but under all the stressful situations and all the things that I'm reading online right now, I am really depressed, and I'm at one of my lowest states at this point. Anyway, and the last reason that contributes to the negativity inside the cell are the potassium leak channels. So there are some leak channels. Let's draw those. I will use this color. Okay. So these channels, I'll draw a few. These channels are potassium leak channels. These are potassium leak channels. Now, leak channels, they are always open. Please remember, leak channels, they are just open all the time. And it is through these leak channels that the potassium trickles out. It's slow movement. It's like dripping. So potassium trickles out via these leak channels. And as potassium moves out, are we losing positive charge? Yes, that contributes to the negativity inside the cell. Remember one thing, leaking of potassium to the extracellular environment is the #1 contributor for the inside of the cell being so negative. So this is the most important, very important. Okay. And honestly, so let's, okay, I'll do another video.